Hi guys, this video is classifying rational numbers. It's in Unit 4 and it is on page 15. So the page numbers are real small at the bottom. I'm sorry, page 11. Page 11. Okay, we have looked at the vocabulary already. We know what a whole number is and an integer. And we're just beginning to learn what a rational number is. So that's our big vocabulary word for today, rational numbers. So, a rational number is any number we can write as a fraction. So a rational number is a number that we can write or change into a fraction. In fact, it is the same word as ratio. A ratio is a comparison of two numbers, so it's similar to a fraction. In the first section, we're going to write each number as a rational number in the form a over b. A and b are integers, and they're in fraction form. If you look at the first one, it's a whole number, but we can change any whole number or any integer into a fraction by doing kind of a little magic trick. 5 divided by 1. Because 5 divided by 1 is 5, then it's still in the same form, and it now is a rational number as a fraction. This one is already a fraction, 3 over 5. Ooh, this one's a little trick. We can change 2 3/4 to an improper fraction with our calculator, and I'll show you how to do that later. But for now, 2 times 4 is 8, plus 3 is 11. These are equivalent. 2 3/4 is the same as 11/4, which is now a fraction. Do you remember my integer trick? Negative 3 is the same as negative 3 divided by 1. So it's now a fraction. Now decimals. Decimals, we just need to say them. You could change this into a fraction with your calculator, or you could just name it. It's 7 out of 10. This one's probably the trickiest of all. It is negative 1 2/10, which is the same as negative 12 over 10. We'll talk about doing that one later with your calculator. This is the same as the whole number 12. And the trick, 12 divided by 1. And another improper fraction. 4 times 2 is 8, plus 1 is 9. This is the same as the fraction 9 over 2. Remind me to show you how to do this with our calculator. Okay, next section, we're going to circle all of the integers. If you want, you can pause the tape here, try it on your own, and then check and see if you're right. Circle all of the integers. Hopefully you pause the video. Here are the answers. Negative 3 is an integer. So is 5. So is 7. 0.5 is not on our number line. Negative 18.1 isn't. 12 is an integer. 25 is an integer. 7, yep. Now this is a trick. It says negative 9.0, but that's the same as negative 9. So yeah, that's an integer. That's not an integer, and that's not an integer. Now all of the other ones are rational numbers. Everything on this page is a rational number. The next section, we're going to circle all of the whole numbers. Try it on your own. Pause the tape. Hopefully you paused. Here are the answers. Negative 7, well, that's an integer, but it's not a whole number. 4 is a whole number. 9 is a whole number. 0.9, nope, not a whole number. 15 is a whole number. No. 16 is a whole number. Well, this is negative 3. That's an integer, but not a whole number. So all of the numbers are integers. These are, rational numbers. Everything on this page is a rational number. These are integers. These are whole numbers. Now in 6th grade, what you're tested over is translating that into a picture and understanding where numbers would go in a picture. So we're going to place these numbers on these two Venn diagrams. This will actually be easier. I think we'll start with this one. I'm going to look for all the whole numbers. We're looking at these numbers down here. Which numbers are whole numbers? Well, I only see one. 17. Now this picture makes a lot of sense because all whole numbers are also integers, and all whole numbers are also rational numbers, so they fit inside of the rational number group, and whole numbers fit inside of the integer group. So this is all three. It's a whole number, it's an integer, and it's a rational number. Let's find integers. Well, negative 3 is an integer. Do you see any more integers on this line? Well, there is one, and it's a trick. Negative 24 over 3 is the same as negative 8. So I'm going to write it in the form it is on here, but that is an integer. Now this is going to be really easy. A little bit dark. I hope you can see with my pen. All of the other numbers go inside of the rational number box. Negative 1.26, 5.9, 4 over 9. All of these numbers could be written as fractions. 0.99, 1.5, and this one 0.333. All of those are integers. Now I hope you could see, if not, 17, negative 3, and negative 24 over 3 go in the first boxes. All of the other numbers go in the dark box, rational numbers. Okay, now we're going to look at this other diagram. These are called Venn diagrams. You've probably seen these before. This box in the middle is where all three circles intersect or come together. So we're looking for a number that is a rational number, is an integer, and is a whole number. All three. Whole number, rational number, and integer. It has to be all three. Well, there's only one that's all three, and that's 17. 17 fits in all three circles on both of these. Now, are there any numbers that are whole numbers left? There are not. So this box, I'll shade this in, this shaded area would not exist. there are no numbers that are just whole numbers but not integers or rational. So this should be blank. Okay, let's find integers. Negative 3. Negative 3 is an integer, but it's also a rational number. So it fits in this box, negative 3. And negative 24 over 3, it is an integer. So it's also going to be, look at the form, it's going to be a rational number because it can be written as a fraction. So are there any numbers that are just integers but aren't rational? No. All integers are rational. Are there any numbers that are whole numbers and integers but not rational? Well, let me think about that. If it is an integer and a whole number, then it also has to be rational. So this box would also not be written in. All of the other numbers fit in this tiny box. 1.26, 5.9, 4 over 9, 0.99, 1.5, 0.333. Now it looks at, on this chart, it looks like rational numbers is the biggest group, but they're all infinite. We could count forever with whole numbers. So all of the groups are very large. I hope this helps to understand. Understanding these pictures is key to getting answers right on the STAR test. Hope that helps.